Hello everyone. We are from GM University presenting topic on parallel sorting with child processes guided by Dr. Shivan Gowda GM sir, HOD of Computer Science Department. I am Bhumika Naresh and here are my friends Koushik L K, Prakruthi K N and Prajwal S Kali. Now my friend Prajwal S Kali is going to continue with introduction.
To start, the goal of this project is to efficiently sort a large number of dataset of 10 million integers by utilizing parallel processing. We focus on splitting the dataset into smaller subarrays, assigning each subarray to child process for sorting, and merging the result into a fully sorted arrays. This method demonstrates the power of parallelism, especially for handling large-scale data processing tasks. We implement the project for both Windows and Unix system, leaving platform-specific interprocess communication techniques like create file mapping and mmap. Now let's discuss the problem we aim to solve. Our object was to divide the dataset into 10 subarrays of 1 million integers. Each sort finally merge the result into one sorted array. Key features of this implementation include efficiently processes management, shared memory for data exchange, and an optimized merging algorithm. With that overview, I will now pass it on to explain how we achieve the inter-process communication and the detailed implementation to Bhumika.
I am here to explain the code of this child processes. This includes file control operations, includes memory management functions, provides POSIX functions, and includes standard IO functions, includes functions like ATIO, converts string into integers, and quicksort for sorting, provides string related functions, though not directly used here. Comparison functions for sorting. Comparison function used for quicksort to sort integers in ascending order declares a helper. Comparison function use quicksort to sort integers in ascending order. Declares a helper function to sort an array using quicksort. Main function validates the two command line arguments start index and size are provided. Exits with an error otherwise. Converts command line arguments into integers for starting index and size of a subarray to sort. Access shared memory. Opens the shared memory object previously created by the parent process. Exits an error if it fails. Maps the shared memory object into a processor's address space for the reading and writing. Exits when an error is if mapping fails. Sort subarray. Sorts the of the shared memory array starting at start index and spanning array size elements. Cleanup. Unmaps the shared memory and closes the file descriptor to release resources. Helper function, a simple wrapper around quicksort to sort the given array of integers using the compareInts function. Now, my friend Prajwal Iskali is going to continue.
Bhumika, it was nice explanation. Interprocessor communication. In interprocessor communication, we explore and implement IPC mechanism using create file mapping and map view of file in Windows for shared memory. Here are some points. Use create file mapping to create a shared memory region that can be accessed by both the parents and child processes. And next, we use map view of file to map the shared memory into the address space of each process, allowing direct access to the data in each subarray. And in Unix equivalent, for Unix based system, mmap can be used for similar shared memory functionality. And next, alternatively, IPC method like pipes or files may be used if shared memory is unsuitable for specific parts of the project. In merging sorted array, after all child processes have completed sorting, the main process should merge the 10 sorted array into a single sorted array. And next, implement an optimized merging algorithm for sorted array to reduce the time complexity of the step.
Performance measurement. Measure and compare the sorting time between parallel and single process sorting. Log execution times for each child processes and for the final merging process. Additional requirements ensure each child process sorts only within a assigned array. Handle edge cases. Example, sorting large numbers, handling duplicate values. Use close handle to properly release resources associated with create process, create file mapping, and map view of while. Ensure the program handles termination of child processes gracefully. Deliverables. Source code for parent.c and childprocess.c. Documentation explaining your choice of IPC method, for example, shared memory with create file mapping versus file based sharing. Steps in the merging algorithm. Observations on performance and efficiency. Execution time logs for analysis, a recorded demonstration of the code execution. Here are the criteria for the evaluation. Sorry. Okay. Evaluation. Here are the criteria for evaluation: correctness, efficiency, IPC implementation, documentation. Correctness. The program should be accurately sort and merge all integers. Efficiency. Efficient implementation of parallel sorting and merging. IPC implementation. Proper use and handling of Windows APIs for IPC, including comparisons to Unix equivalents. Documentation. Code clarity, comments, and detailed analysis of performance. Now, my friend Kaushik is going to continue with parent processes.
Overview of parent process. This program demonstrates parallel processing for sorting a large array using shared memory and child processes. Here a short explanation. Main array generation. A large random array of integers is created main array. Shared memory setup. Shared memory is created using SHM open and mmap to store the array, allowing child process to access it. Then, for child processes, the array is divided into equal parts. Each child process is tasked with sorting one part of the array using an external program. Then, sorting in child processes. The array children sort their assigned subarrays. Then, parent process waits. The parent waits for all child processes to complete using wait pair. Then merging results. After sorting, the parent merges all sorted subarrays into a single sorted array using a min-heap based merge algorithm. Lastly, cleanup. The program cleanups shared memory and other resources. This approach demonstrates inter-process communication and partialization using shared memory and child process. Then Prakruti will continue.
Hello everyone, I am Prakruti. Now I will explain the code. It includes required libraries for shared memory, process creation, and utility functions, defines constants for the array size, number of child processes, and subarray size of each child. It allocates memory for the main array and checks if the allocation is succeeded. Populates the main array with the random numbers and creates a shared memory object for the inter-process communication. It sets the size of the shared memory to hold the entire array and maps the shared memory into the processor's address space for access. And it copies the main array into a shared memory. It forks child processes. Each child sorts a subarray using an external program, child program, and passes its starting index and size as an arguments. The parent waits for all the child processes to finish sorting and allocates memory for the final merged array and checks for allocation success. It creates an array of pointers, each pointing to the sorted subarray in a shared memory, and merges all the sorted subarrays into one sorted result using a minute heap approach. It cleans up shared memory and deallocates dynamically allocated memory. It fills an array with the random integers and merges sorted subarrays into a single sorted array using a simple iterative approach with the index tracking.
Now, here are some key points of support code in parent C. Create shared memory with create file mapping, and next, map this shared memory with map view of file for access in both parents and child processes. launches 10 child processes using create process with unique command argument specifying each child subarray's start index and size. Next, walls for child processes to complete with wait for single objects. And next, it merges sorted arrays after all child processes have finished. Next, in child processes.c, it accesses the shared memory using open file mapping and map view of file. And it receives the assigned array segment includes via command line arguments. And next, it sorts its assigned segment and then terminates. This skeleton structure provides a clear outline of the approach handling child process creation and mapping, memory sharing, and array segment sorting.
Thank you everyone for patiently listening to us. Hope you guys got some information about this topic. Now it's time to thank our beloved lecturer for guiding us. Thank you, sir. And thank you, my teammates. Thank you, guys.